Yeah, how are we? Yeah, fine. Now today we are back for the next topic, general angle and their properties. Now, before we can move on, I always prefer to check students whether they have really whether their brains are properly working. Otherwise, the brains might have got mechanical crash down. Now, Precious, is your brain working properly?
Yes, sir.
It's working properly. Natalie, is the brain working? Grace, you look to me that the brain does not work. It works. See? Now, in brief, let's see somebody to answer this question. There are two. To just check whether the brain is working. How many times can we subtract 9 from 50? How many times can we subtract 9 from 50? We want to see whether the head is really working and attentive. Yes, Grace, you said you have an answer. How many? You want to try, but you told me your brain is proper.
I think we can subtract 9 from 50 5 times and remain the same.
5 times. Okay, you've tried. Then in Natalie, how many times can you subtract 9 from 50? The answer is like 4 for Precious, for Grace, 40. How many times do you subtract 9 from a number called 50? People have not answered that.
You can subtract 9 from 50. Then 5 times.
5 times?
Yes, then you will.
Now, that one you have tried, but I'm wondering whether it's correct. But then, let me ask this. This is just me and my family. We are 4 children with 3 boys and 1 girl. How many children did my father give birth to in the hospital? How many? In my family we are 4 and 3 boys. How many boys did the father give birth to in the hospital? No child. That's very good. Why? Men don't give. Yeah, that's wonderful. Now we start. Your answer for how many times can you subtract 9 from a number called 50 It's only once. Because when you subtract 50 minus 9, you receive now 41, and it's no longer 50. Yeah. Yeah, thank you very much. Let us go on with our lesson also. Now that's math. Since we keep learning, I wanted to tell people, those who want to learn to multiply in 9, to multiply without a calculator, you can just even put the answers without. Yeah, definitely we get 9. Now, the easiest way is just fill these numbers 0, 1. This is 6 times 9, 7 times 9, 8 times 9, then 9 times 9, etc. Now this will be 5, 6, 7, 8, and 9. That's 9 times 10. Then for this part, we write, this is 0, 1. Here we go in introducing what? 8, 7, 6, 5, 4, 3, 2, 1. Yeah. That means you can easily fix answers for multiplication in 9. Those are simple. I'll be giving you many that any number times 9, instead of you suffering with the calculator that you don't have, just multiply by 10 and subtract 23. That means you can do it from the head. 17 times 9 is 1. 70 minus 17, which is 70 minus 17, which is 53. 153. Somebody's wondering, you can multiply things in the head. Oh, okay, fine. Those were just a by the way to just keep giving you more tricks. Now these days we are ceasing to multiply with the calculator by developing the codes that the calculator has. Now our topic 7 is general angle. General angle and angle properties. Remember that we last looked at bearings. Is that very right? Now under here, it's not very big. We are going to have various subtopics under here. We are going to look at meaning of an angle, meaning of angle. Look at how to measure angles, measuring angles. Then look at now types of angles. Then you got angles in polygons. That means we shall see polygon properties, then angles and polygons. Properties of polygons. Then lastly we see angles in polygons. Yeah. And some polygons, constructions of polygons. Yeah, those are our subtopics, and that means that topic is not very broad. But I request that you pay maximum. Yeah, because it's bad to talk to yourself. They will call you a madman, not so? Yeah, but sometimes it's good to talk to yourself. Yes, you can talk to yourself. It's not bad, it's sometimes good. Then meaning of angle. What does the word angle mean? See, that assuming you are to measure either this way or you measure that way, you are still measuring an angle. Yeah. You can either put a protractor here or you can put it on this line. Yeah. Now, an angle, I think we just see that you are turning about a point, not so. An angle is a turn about a fixed what? A turn about a fixed point. Now, let us go to measuring angles. Measuring angles, and that will help us even apply it in forming what we call pie charts. Measuring angles. And here I will request you to draw some lines which are at an angle to each other. Then you try to measure that means I expect you to draw this, the first, and you measure that angle. Then I also expect you to draw that and measure that angle. Then I also expect you to draw that and measure that angle. That means measure angles in each case. Now, how do we measure this angle? Using a protractor. How? It has two scales. The inner scale that has its zero this way, and the outer scale, not so. Now, if you are using the inner scale, then the line where you are starting to measure from must be on this one. Like if you decided that let me measure from here going up, then the zero must be on this. And the middle of your protractor must be where the lines meet exactly. And this line must lie along that line. Prolong this line so that it goes past your protractor so as to be able to measure. How many degrees is that? 50 degrees. According to you, yours is 50 degrees. Now this is here. This is now, mine is around, using my inner scale, it is around 56 degrees. Another student might want to measure from this line. That means you can either put now the zero. Here you'll be using the outer scale, and it still gives 56. You can measure clockwise or anti-clockwise, 50 degrees. Then how do we measure this inside angle there? The outer scale here. Then this middle must be here. The inner scale, not so, because zero is here. Up to there, not so. How do we find this outside one in case I wanted it? In case I wanted that external one?
You first find the remaining angle this side,
Mm.
the inside one. Okay, teacher, according to since a complete circle is
360.
so you first find that
The inside one, then you subtract. That's 230. That's exactly. Yeah. Now, I hope you can even measure this internal one and measure the external one. Period. Types of angles. Types of angles. Now, wait a minute. Before you reach types of angles, I request that we can get some information and plot a pie chart to apply the concept of measuring what? Angles. Before types there, you can first answer this question. You can first answer this question on a pie chart. We just apply the concept there to measure the necessary angles. The necessary angles. Necessary. Are you ready? Yeah, it says here that the number of AIDS activists, the number of AIDS activists, the number of AIDS, let us use it, AIDS activists, yeah, in 4 different villages is as shown below. In 4 different villages is as shown below. In 4 different villages is as shown below. We start with Kitaka, then you go to Chitende, Namunga, then Kanga. The 60, 35, and 30. Represent the above information on a pie chart. How do we achieve that? Pie chart. Yes, Grace, you want to guide us how we achieve that?
So we shall first find the total.
We shall first find the total. Total number of activists. Yes, that is 30 plus 35 plus 30. Then
after finding the total,
that means what the next item is to find?
you find the degrees for every.
The respective angles.
Yeah, every.
Angles. That means Chitaka will have 30 out of
155.
This is 155. Then what else?
Times that to
360. That one gives us kitende. We are rounding that angle to?
Rounding it to 70 degrees.
To a whole number, because a protractor does not give anything beyond that. Namunga is 35 out of 155 times 100. Okay. I hope you have got the values. You have got the values, not so? What are the angles there? You have calculators. Precious, what do you have here?
I have 139 degrees.
The calculator can even round for you if you don't know, but you must know because we saw it in topic 2. Yes. This one?
I have 81 degrees.
81.
Then that one 70 degrees.
70 degrees, because it's the same.
Yes.
Okay, now we form our pie chart from that information. We can't fail, not so? I will not rub the angles, but can leave them there. How do we start? It's better to start with the biggest angle. Of course, we have to first locate one starting line. Not so? And angles are going to be measured from that one. We are set, not so? Our first angle is, let me increase this length of my pie chart.
139.
But make sure you first have to what? To have a big circle. Yeah. Get what radius do you use? You draw a reasonably big one, fitting in the space provided. My space can permit me to extend to this. To the what radius do you extend it to? No. My point is here. Are we right there? Then we mark the starting line. Mark where to start. That is clear. Then we measure 139 first. 139. My inner scale, 139 is roughly here. Roughly there. That's 139. Not so? Then next one is next big one is 81. We continue. You see my protractor was like this. I'm just going to, not so? I just keep continuing. 81. 81 is roughly here. Where I end is my starting point. My starting point. Point. That's now 81. The next one. Now, since I ended like this, remember it was like this. I turned it this way. Now again, I what? I turn until this line gets a what? I don't understand, but not says. The 0 was here. Turn, you reached here. Turn again, you reach here. That is, then the next angle is 70. Inner scale still 70. Yes, that's right. Now you don't need to measure the last one, since it's remaining only one, it will also be. Then you mark what's found there. This is Kitaka. Not so? 81 is Namunga. Then 70 is 139 was Chitende, sorry. Chitende, Chitaka, and Kanga. Pie chart concept, somebody's clear now, not so? Excuse. You should write a title. Even if it does not earn marks, but now which you see, this is used in data representation. Therefore, you must define what you are representing. A pie chart showing a pie chart showing number of AIDS activists, number of AIDS activists in 4 different villages, not so? Thank you. Now we are going to the next subtopic was types of angles. Types of angles. We are removing this. Now this pie chart, they can ask you which villages had the greatest number of activists. That means pie charts, any diagrammatic representation of information is easier than reading data from the tables. Now, types of angles. We have so many. Do you recall some? Yes, Natalie. Obtuse angles. We are going to write about each. Yes. Natalie's answers have ended. Let me hear from somebody else. They have not ended, but she might give all your answers. Please also give before she gives all your answers. Precious, which angle do you know? You only knew what was in her head. You only knew those. You also knew those ones. You mentioned her answers. Then reflex angle. What else? a right angle. This also commonly called what? Right angles. A right angle is actually what? That's what? It's 90 degrees, not so? Then we can isolate it from its friend called complementary, though they mean the same thing. What else? Straight angle. We can also isolate it from supplementary. But why isolate? They mean the same. Complementary angles that add up to 90. Supplementary add up to
180.
Yes. That means they are straight angles, not so?
Yes.
And that's right. Supplementary angles. What else? You have so many angles that you saw in interior. We shall not isolate it from interior and XT. They'll work together. Alternating angles. Its friend is what? Its friend is? Let me help you with one. Corresponding angles. Yeah. Yeah. Co-interior. Why not speak about them under interior? Co-interior. Can angles be interior and they are not co? To be co is to exist together, not so? Now, start with what? Acute. We answer them in order. Acute angles. What are those?
These are angles that are less than.
Angles that are less than. Is zero acute? Zero is not an angle. 0 degrees is not an angle. They have refused. Yeah, because you measure from 0 degrees to 360 to complete all those. Okay, HI, vertically opposite. Opposite what? Then angles at a point. Yeah, you can find more. Is 90 degrees acute? No. No. Now, obtuse angles, for them they obtuse angles are more than 90 degrees but less than 180 degrees. For example, 120 degrees. Yeah, we are moving, not so? What are reflex? Yes, Natalie, a reflex angle. They are less than 360. These are angles greater than 180, but less than, yeah. are greater than. Now we can visit complementary angles. They are angles which add up to 90 degrees. That means they form a right angle. Now we are going to straight angles or supplementary angles that add up to 100, 880, or angles on a straight line. Now, could we try to find out whether that concept is true about supplementary? If I ask you to draw that line, then draw a slanting line and measure angle A and angle B and add them. Do they really add up to 180 if you use a protractor? They do. You've measured or you are thinking so? It's obvious. It is obvious. It is obvious. It is like that. They add up to that. Interior angles and exterior angles. Yes, what are they, Natalie?
Interior angles are angles
found inside a polygon. Inside a polygon. Then exterior are found outside, but not only a polygon. It can be some even in transversal lines. There can be, not so. But interior is to be inside, not so. Exterior is to be outside. Now, I'm going to handle corresponding and alternating angles together. Are we there? Now this was okay. Let us to correspond first because people need corresponding angles. What is to correspond? To be equal to. To be equal to. To correspond to the same.
Just because they are opposite, but they are the same.
Now, to correspond, maybe we can pick it from those slanting, assuming I slant this, what could correspond mean to you in that if this is A, this is B?
Yes,
to correspond is to match and look the same, to match exactly. Corresponding angles are those that match with each other in size, not so? In size. A equals B. Is that correct? That's right. Now, that means even if I draw my structure that way, this will still, the size of this matches the size of that. Yeah, D and C. That means A is equal to B because A is corresponding to B it looks the same. Alternating angles, alternating, what are they? To alternate. You have a view?
Like to alter. You see, like if D, the way D is,
Yes.
on that slanting line, and is where C is, but on the other side.
Okay, let me put my things there. But on the other side, that means corresponding will always merge in and kind of this pattern.
Yes.
A and B. One is the other side and one is the other side. Could we say this corresponds to this?
No.
I mean to alternate. These are corresponding.
Yes.
This alternates with the what? With this. Does it come to your attention that way? To alternate is to be on one side and the other one is on the other side, but you look the same. To be oppositely facing each other. Oppositely facing. Oppositely. No. Now we are going now to go into deeper analysis there. Yeah. Does this what could this correspond alternate with? The other side of the line and this side of the line. Could that go to your head?
Yes.
It is the other side of the line, this side of the line. You have obvious. We are going to combine them together.
And is it also possible that it can also be opposite if down
Here. Now those are going to be under vertically opposite and angles. Yeah. We move, not so? Yeah. Corresponding angles and alternating angles in transversal and parallel lines. We are still on types of what? Angles. Now you must understand, because we are going to do numbers now of determining which value is this angle. In transversal and parallel line. Now we can say that we did the construction and we know what parallel lines are, not so? Now if those lines are parallel and I happen to draw an intersecting line, that line is going to be called a transversal line. That's a transversal line. Now, let me fix the angles and people can detect which one alternates. Which one alternates who? Pairs of alternating angles. Alternating angles, let us see. Then you also need the pairs of corresponding angles. I will also need the co-interior angles and the co-exterior co-interior. Which ones are co-interior angles and co-interior angles and co-exterior? Co is is existing together. Yeah. Pairs of alternating angles. Which ones are alternating? Yes, let me pick one by one. Let me start here. B and I. B and I. That means they are equal, not so? Any other pair? I think you work out all these. B and I. What else? You are finishing your part. Yes? A and J only. Should they help you? Yeah. A and F. A and F are what? Alternating. Those are vertically opposite.
No, teacher. A and H.
A and H. A and H. Are you sure they are equal? Does this alternate this?
No.
No, not at all. Not at all, not at all. Is this even correct? A, B and I?
Yes.
B and I. They are alternating, yeah, this side, the other side. A and J, A and J. This side, this side. Then F and G. That's right. Then E and H. That's very correct. That means these pairs are equal to each other. Corresponding B and H. Yeah. B corresponds to H. What else? A corresponds to G. Is in the same form as G. To correspond is to be in the same form. E and I. E and I. F and J. Are they over? What are those co-interiors that are together? In the same side, EG. EG. Now the property EG, the property of co-interior is that they add up to 1/8. Then F and H, yeah. F and H, they also add up to. What are those co-exterior? A and F. Those are vertically opposite. Vertically. A and I. A and I, they also add up to, and I add up to 1/8. Then B and J and J. Yeah. That's exactly. Now we are trying now to move ahead to now vertically opposite angles and angles at apo. That's true. Now we are clearing this material, not so? Yeah, you must know these things. Yeah. We are still on types of angles. Remember that we have not left types of. Remember that very, very much. Remember that. Say that. Now, vertically opposite angles and angles at a point. Yeah, hope you are aware of that. A, B, C, D. Which angles are vertically opposite? Yes. B equal to D equal to C. Now, the sum of all those angles equal to? Because these are angles at a what? At a point. Whereas these are vertically opposite angles. Opposite angles. Now I want to give you some one or two numbers. We apply those properties. Yeah, one or two numbers. So things are easy, not so? Yeah. I also believe that things are. You are very, very much set. Find the value of A, B, C, and D. Find the value of A, B, C, and D. A, B, C, and D in the diagram. A, B, C, and D. That is C, D. A, B, C, and D. A, B, C, and D. Can I have reasonings? You give an answer with a reason. Yes, Natalie. A equal to reason. Vertically opposite. These are parallel lines. Parallel lines. Vertically opposite. Next. Vertically opposite. Yes, Grace.
D is equal to 45.
D equal to 45. Reason.
A is 45 and they are alternating.
Are you correct?
Corresponding.
They are corresponding angles. Corresponding angles. Then next.
B.
B equal to
45.
45.
Alternating.
B equal to 45. Alternating with who?
With 45.
Are you sure? It alternates. That this is equal to this.
No, teacher, I think B alternates with.
B alternates with A.
D alternates with B.
B alternates A.
No, it corresponds with. No, it corresponds with.
They are arguing, not so?
B equals to 45.
B
Alternate
with who?
with 45.
You are very, very sure? This one alternates this. How?
I don't.
How can you explain that?
Teacher, maybe because
To alternate is to be on this side and the other side. That means it's right.
yes, because they are both outside.
Ah.
Teacher, if you don't agree with that, it's also another one.
Eh.
You said D equals to 45.
Yeah.
So, yes, but
I agree with you in both cases. I had doubts, but now I agree, fully agree. Out of C.
180.
Why?
Reason being, B and C are on a straight
On a straight line. That means B plus C equals?
180.
This is a straight angle. Straight angles. You can now, that,
Even another one.
yes, another one.
For C findings, I'm just suggesting.
Suggesting, is the suggestion correct?
I think
Yes, go ahead to suggest.
it's the
That's around? It's what? You have refused to finish it.
teacher, and also we already know for D. So
We
can
already
also
know
make
for D.
yes, C can be
A straight angle with?
with D.
That's very true. That's
Or
true.
you can opposite.
I don't doubt that. Unless it is you who doubts it, not so. Yeah, now I want to shift you to, hope the concept has been picked. Now, I want to throw you, to throw you is to introduce you. But before that, you also have another one. Question it to find the value of x and y in the diagram. X and y. People will reason not so. That's 40 degrees. This is y plus 40. That's x plus 40 degrees. What's the value of x and y? I'm seeing the hand there. What is your hand saying?
The value of Y.
The value of y.
I'm not sure, but I believe it's right.
Mm.
The value of Y is 0.
How did it become 0?
Angle 40 and angle Y plus 40, they are vertical angles.
They are equal. Do you mean they are equal?
Yes.
Oh, then subtract 40 on both sides.
Yes.
Vertically opposite are. That means y is 0. How do we get x? With reason. Yes, patience.
Since we've got the value of Y, then it's simple to get the value of X.
Since we've
Got the value of Y. Since they are both co-interior.
these, they are both co-interior. What happens to them?
X plus 40
X plus 40
plus 0, which is 4,
plus 0.
is equal to 180.
Are you correct?
Yes.
You are not correct. Why? Are you not correct?
Plus 40, I mean, 0 plus
Plus 40. X plus 80 is 180. X plus 80 minus 80 is 180 minus 80. X is equal to 100. Yeah, you can have as many as possible. Now, I want now to shift it to properties of polygons. What is a polygon? Now we're on polygons. Yes, let me hear from people. Polygons and their properties. Yes, Nantale, can you speak out what's a polygon? I see your hand up.
Polygon is any-sided.
Polygon is any-sided.
Yes, okay, like it can have any number of sides.
Any-sided something. Okay, that's right. Thank you. Grace, you seem to doubt her answer that it's any-sided something. You believe the answer is correct. Okay.
What I'm trying to say is that, okay, it's somehow like hers, but just because of the words, yeah. Okay, a polygon is any shape with well-defined sides and edges.
Any shape with well-defined sides and edges. Edges. Okay, how would you define this polygon? Why is it called a polygon? Yes?
I think a polygon is a shape with sides that are enclosed.
Say it again.
A polygon is a shape with sides that are enclosed.
With sides that are? Does this qualify to be a polygon? See. Yes.
It doesn't have sides and edges like
It doesn't have sides and edges. That means a polygon is a closed figure with straight sides. She said it is enclosed, but it must have straight. Yeah. Now, examples of polygons. Yeah, people have very many polygon. Then the shape, then the properties. Now, before you give me your polygons there, you are also going to remind me that there are some polygons which are regular and some are irregular. What is to be regular? Yes, what is to be regular? I can have, who is very sure? Nantale?
an understandable shape. Like, let me say, if you find a name that is irregular, it doesn't have an understandable shape.
See.
Like sensible shape.
It is to be sensible. To be regular is to be sensible. To be understandable. Is it to be uniform?
Teacher, for many things, to be regular is like to have at least either, okay, like some sides in common.
Some sides in common. In equality. She said to be understandable is to be regular. She took it much more to be English. Regular is to be equal in size and in length, and in that means in length and in angle. To be equal in length and in angle. Yeah, she took it, explained it in the English way to be understandable. Yeah. A regular polygon is one containing all sides and angles equal. Then irregular has all sides and angles not. Yeah. The first polygon is triangles, and here I would like you to mention them three. What is that type? Equilateral triangle.
Is a line a polygon?
Is a line a polygon? I also don't know. Who can answer that question? Is a line a polygon with a reason? Yes, Grace.
So for me, I think a line is not a polygon. Reason being a line is not an enclosed figure, and yet a polygon is meant to be enclosed.
I have no rights to deny that answer. Unless the one who asked has the rights to refuse. Yeah. Now, I would be convinced to speak. This is equilateral. Remember that triangles are how many? Equilateral, scalene, isosceles, right. Now, okay, here I had to write the name equilateral triangle. Then here I have to draw the shape. Properties there in terms of sides, angles, and symmetry. Now there are two symmetries here we are talking about here. There is what we talk about as the line of symmetry, and there is what we call, we shall, I think, limit ourselves to the line only, though I will ask you to go and read about what we call rotational symmetry. Yeah, that if you rotate this book about an axis, you are going to read about rotational symmetry. If this book is rotated, if I tied this book to any axis and rotated it until it comes back to where it was standing, you rotate it through 300 what? 6, it goes around and comes back like that. Rotational symmetry is just the way, the number of times any a figure remains the same when rotated, looks the same when rotated about 360. Can you rotate it like this and it looks the same? Like a rectangular shape has the rotational symmetry of 2, because you can rotate it this way as well as you can rotate it any way, and you can always return back. If you rotate it like this, it will still stand. Rotate like this. If you try to find out if you rotate it like this, does it return back? You try to work out you read about rotational symmetry. Yeah. Me, I will limit myself to lines of symmetry. And most of them, how do we get a line of symmetry? Could you demonstrate? Nantali, come, I give you a paper. Or you want to demonstrate from here or there? You look very good in the camera. You look very good. Do you have a paper there and you give her? Yes, you are going to demonstrate to us how do we get a line of symmetry. Yeah, Nantare.
Symmetry is got if you divide a figure and you get two equal parts.
If you divide, say it again.
If you divide a figure and you get two equal parts. Now this, if I divide it very well like this, so these parts are equal. This one and this one are equal.
They are
So if
equal.
I divide this, they will be equal. Then there is also this one.
That will be equal.
Still, they will be equal. This part and this one will be
Are equal.
Then you can also divide it.
Why is dividing? Why is dividing along that line you were last talking about wrong?
There are no works on squares.
There would be
The other line I'm saying only works on squares.
only works on squares.
Well, like
Squares. It only works on squares. See, only works on square. That's very good. That's very, very good. You can send us that paper and we see. Yeah. Send us that paper, Precious. Only works on squares. Yeah, she demonstrated that whenever you fold a shape and the edges line with their friends exactly, that this one would line here and this side would line with it. See, that when the faces line exactly on each other, they lie on each other exactly, then that's first line of symmetry. If we fold it again like this lies on the other one exactly. But if you fold it like this is a rectangular shape, fold it at a diagonal. I hope you see. They don't lie on each other. But if it's a square, they will lie. How many lines of symmetry would the rectangle have now? 2 lines of symmetry. A square would have 4. Yeah, 4 lines. 4 lines. What of this? If you folded it here, it would match.
yes.
Folded it here,
No.
it can't match.
Yes.
Here it can match.
Yes.
Then fold it here.
No. It can.
This can't touch this.
It can. Reason being that it has equal side.
How many lines of symmetry? 3. So all sides and angles are equal. All sides and angles are equal. Has 3 lines of symmetry. Another triangle here. Isosceles has how many? How does it look like?
It has 2 sides.
It has 2 sides equal. Oh, that means we shall visit that later in the angles, that the 2 angles are equal. Oh, then it would have how many lines of symmetry? That means I'm going to ask you to talk about line of symmetry and the angles. Each will be talking about line of symmetry and the angles. Which other polygon do we have under scalene triangle? What is true about it? All sides are totally different. All sides are totally different from each other. Would it have any line of symmetry? No, no lines of symmetry. Yeah. That means I would like you to state the lines of symmetry and the nature of angles. Here 2 angles are equal, and there are base angles that are equal here. A is equal to B. Then we have a right angled triangle, which can be scalene or can be any. Can be scalene or isosceles. Right angled triangle. There are others which you can have obtuse angled, but they will definitely fall under that. Obtuse angled triangle, I think somebody would figure out how it would be. It must have an obtuse what? Angle. Of course, all that we are mentioning here are going to fall in the upper category. The key is equilateral, isosceles, and scalene. Then these ones can fall in any of those categories. Obtuse must have an obtuse angle somewhere, any angle beyond the 90 degrees, but less than. Now that is taking me to other polygons like the square. We have a square. Then what do you have? Rectangles. I think talk about sides and lines of symmetry. Rectangle. Talk about sides and lines of symmetry. This has 4 lines of symmetry because they would be everywhere there. Rectangle has 2 lines of symmetry and has 2 lines of symmetry. Don't forget to read about order of rotational symmetry. Order of rotational symmetry. For each polygon there, you go to Google and read about it. How many times can they rotate a shape through 360 and it looks the same? Yeah. Rectangle has 2 sides equal, not so? Now you can also investigate that it has some lengths called diagonals. When you draw from one corner to another now, what is the name of each corner of a polygon? This corner is called, each corner is called a vertex. Vertex. Rhombus. What is the property of a rhombus? All sides are what? Are equal. You will investigate its lines of symmetry later. That means have a part for lines of symmetry and the sides and the angles. Yeah. Parallel. What do you know about a parallelogram? 2 sides are equal. Don't forget to label its diagonals. Its diagonals. I hope you can figure out the lines of symmetry of a rhombus even by observation. Yeah. Fold it around here, this will fall on this. Fold it like this will fall exactly. But you can't cut it like this, it would fall. If you fold it and surround here, it would fall in a different. Yeah, it has 2 lines of symmetry. Then this, how many lines of symmetry that could you think about? Parallelogram. Any? If you fold it like this, does this fall onto this? No, no line there. If you did like this, does this follow here? No, no line. If you did like this, does this fall on this?
Yes.
Exactly. It does. No, if you divide equally, not so and you fold. I'm seeing this folding in space here. No, you try to fold and see. See, you fold here. This seems to follow here. They are folding past each other. You'll cut a parallelogram shape and try. No line of symmetry. Yeah. What other polygon do we have? Yes, trapezium. Now remember that we finished three-sided figures are called triangles. Four-sided figures are called quadrilateral. Say it again.
Quadrilateral.
Do you mean I'm defeated too? Do you mean I'm defeated? Now. Yeah, now go on Google and type in line of symmetry of any you want, you see, and try to investigate it by cutting papers and other shapes and finding out that that's the truth. See, that's the truth. Fold it if it works, you see, if it works, yeah. Now, we talked about trape. Now the trapeziums are many. You can have the one that has one side looking different. You can have the one with triangles that are the same. Not so. You can have another trapezium. Which one has a line of symmetry? Yeah. Now we were having the trapeziums, and we realized that one of the trapeziums can have a line of symmetry, but you realize that some don't have lines of symmetry, like this can't have, but this can have. Of course, when you try to fold it here, the other side folds exactly onto this one. Is that very sure? Yeah. Now, all these are quadrilaterals. Did we say that? The four-sided shapes are quadrilaterals. Now, we can move from three-sided to four. Then now we are going to five-sided. Five-sided shape, now there the names develop. Yeah, five-sided shapes. Oh, now we have finished quadrilaterals. Now we are on five-sided is pentagon. Thank you. Pentagon. That's five-sided. Remember we said it can be regular or irregular. Regular we mean all sides are equal and all the interior angles are also equal. Yeah. Interior angles are equal and all sides are equal. Now a regular pentagon, I think, can be easily drawn. It seems not to come out, you see. That means, let me get my ruler right here. That means you can easily draw a pentagon. Pentagon is five-sided. We shall work out the interior angles later. I've tried to draw that, but we shall construct them later. Now, I'm going to also ask you to investigate the lines of what? Symmetry. Where would they match? Where? There is this one. Yes. Here also?
Yes.
I think they are quite, but you'll check. You can draw those things and check. But you can also check from Google and watch some YouTube demonstrations. Then we have another one. Six-sided. Hexagon is six-sided. Hexagon. That means that you make sure all sides are equal, not so? Yeah. Hexagon is six-sided. You'll add more. What the next one there would be after septagon? Now what is a heptagon? They are both 70. You can either use septa or hepta. 8 is octagon. 9, 10, decagon. 11, nuo, decagon. 12, decagon. Now, I've left this and I'm shifting my areas to capture now angles in polygons as the next subtopic. And you'll check the sides, check the lines of symmetry and order of rotational symmetry. Order of rotational symmetry. Now, yeah, we are now dropping to angles in polygons. Angles in polygons. Now we start with the triangle. Angles in a triangle. Now, we shall demonstrate the triangle properties ABC, C. If I have another one here. Now look there. What is the angle sum of a triangle? 180. Angle sum of a triangle equals 180. That means angle sum, or sum of interior angles. Now, that's one of the properties. What properties there between C? B plus C will add it to what? 180. These are angles on a straight what? Angles on straight line or supplementary angle or straight angle. What is the other fact about C being equal to A plus call this one D, sorry, that's D. D is equal to A plus C. Which property is this? A sum of two what? Interior. Opposite interior. Sum of two opposite interior angles add up to what? One exterior angle. But this property you didn't again allow me to exterior plus interior angle, you get still 180. This was the same property that we're speaking about here. Yeah, that's very, very correct. Yes.
Why is it that all the interior angles of the triangle are equal to 180 and all the co-interior equal to 180?
That question is very, very complicated. Say it again.
Like all the angles of the triangle
add up to
180 and then co-interior angles add up to 180.
two interior angles. But not in a triangle, not so? Can these two add to 180? No, not in a triangle. Co-interior. See? Now, we are going ahead. Now, assuming you have a triangle which is isosceles form, what is the fact here? The fact is that the base angles must be, because the corresponding sides are. Now, allow me to add. Allow me to add. You see, we are in the properties, playing in the properties. We are playing in the isosceles. Now, I'm not saying this property, other properties, I'm just pulling it here now, and I'm trying to find out something here. Now, then here, I hope, do you realize what I'm trying to develop? A, B, C, D, E, and F. Now, what is the property A is equal to B because corresponding sides are? Did you mark that? This side and this side is equal. These are equal, therefore the base angles must be what? Equal. The angles in that enclosure must be equal. Yeah, equal. Now, yeah, are equal. Now, what is true again inside there? A plus B plus C, you say this 180, angle sum of a tri. Now, what is B? What is D plus E? And what is D E and F are what? Exterior. So the sum of always for every polygon they must add to, that's correct, the sum of all exterior angles of any polygon. Any means every, yeah, add up to 180. 360. That's right. Now, yeah, that's right. Now we want to go deeper there. Let us pull in another category of a polygon. Now we are going to four-sided, not so? Yeah. This property is captured where? Now, four-sided, quadrilateral. But I wanted us to find it out. Quadrilaterals. Let me play around it. Let me draw any shape, but as long as it is four-sided. Don't mind whether it's a triangle or what. So, now, A, B, C, D, A, B, C, D. The angle sum will add to what? Let us see. Somebody might. 360. There you are.
Shall I say 360?
360, why?
Because even though it's a square, 90 plus
90
plus 90 plus 90 is
360.
360. Even though it's different,
Well, what is the key reason for this? Yes?
teacher, for me, I think it's 360 degrees.
Why?
Because if we are to look at A and B, they are both on a straight. B and C, or A and B. I mean B and C, or A and B, they are both on straight lines, and perhaps, yeah.
And perhaps.
Just right.
And perhaps.
Okay, teacher, and see the angles are equal to each other. A is equal to D, and
Now,
B is
let us play it this way. She talked about this one having 90, 90, 90, not so? How many triangles can this form? How many triangles can this always form on division? It always forms? How many triangles are formed? To notice so. This has a 180 total, this has 180. Therefore, it means you can investigate the angle sum by drawing out the triangles inside.
so meaning given that one for A has two. Meaning all quadrilaterals have two.
Have two triangles.
But they have a query there.
Yes.
A triangle, a rectangle, sorry. It can't be divided diagonally and give to equal side. So, like lasagna or sandwich, you want divided.
But is this triangle similar to that? Even if they are not similar, but as long as the number of triangles formed in a polygon also gets you the angle sum. Not so? Now we would check it like this. A triangle has how many sides? 3. Not so? Now, If you are saying this is giving 360 as the angle sum and the triangle gives what? 180. How could we get that formula? This is 4-sided, gives this. 3-sided gives that.
Find the number of triangles.
How do you find the number of triangles inside there first? And the 4-sided has
So how many things will be tied? Because that angle for the lateral and then that for that to get the number of triangles.
you divide to get the number. That's quite complicated to me to understand that. A 4-sided gives how many triangles? 2. A 3-sided does how many triangles? This one that gave us 180 had how many triangles? How many triangles are these that yield this?
1.
3-sided figure has 1 triangle, not so? 4-sided figure has how many triangles?
2.
How can we get the number of triangles in any polygon if 3 sides has 1, 4 sides has 2? How do we know that 5 sides will have how many triangles without even drawing through to check? How many? It would have 3. Simple formula. Assuming n is the number of sides, how many triangles? What do we do? N is the number of sides. These are 4. Has 2 triangles. This is 3 sides. Has 1 triangle.
Who do you think you have to first get the sum of all angles in that?
You are taking us much deeper and harder, not so?
I think there is additional one.
How many triangles are going to be here? 3. Where will you put?
1 is across.
Here.
Yeah.
Then here.
Yes.
Finish. And when you cut through, you will not have triangle. It's a 1, 2, 3. 3. Not so? Yeah. Therefore, if there are 3 triangles, multiply by 180, you get. And now that will be hectic to somebody. Why not a simple formula? Suggest a formula.
If you say square and you divide it twice like diagonal, like this.
How do you know? That you are crossing through the triangle again. You don't cross through a drawn tri. She's saying that if you'll be crossing through this triangle. You can't cross through. You see? Now you have failed to tell me. 3 sides, 1 triangle. 4 sides, 4 triangles. 4 sides, 2 triangles. Number of sides. It is a logic. It's boiling the head. It's brainstorming the head. If a 3-sided figure has 1 triangle, a 4-sided has 2 triangles, 5-sided has 3. Maybe let us use what? Sequence. 3 sides, 1 triangle, not so? 4 sides, 2 triangles. Not so? 5 sides, 3 triangles. This is 3.
Can I explain?
Yes.
Just explaining.
You have 1 minute.
You see, quadrilateral slow polygon start from 3, and 3 has 1 triangle. Like that, so you get the number of sides.
It is n.
Yes. Minus
N is the sides.
minus, like I say, like if
We subtract what?
subtract the number.
What are you subtracting from n to get? How many? What do you subtract?
It depends.
No, you have a general rule. 3 is giving you 1. 4 is giving you 2. There is a difference of what here between n or how many? There is two rule here. Minus 2. That means now we are going to say, we are going to put our formula that angle sum, you believe that? Angle sum, interior angle sum is equal to number of triangles, which is this, times 180. Yeah, that's true. Now I want to get another formula for exterior angles. If we add all exteriors and we get 360, you see that if I prolong alternatively, yeah, if these angles, let's say you have MN TS, and we are claiming that the entire exterior gets us 3 what? You have marked here that N is the number of what? No, this is called the number of triangles, the subtraction, but N is the number of. Now, did you say that exteriors added is 360? That's right. Now, interior angles all added is 360. How do we get one exterior? How many interiors are there? How many exteriors are there? 4. Not so? 4 exterior equals 360. Therefore, every exterior is got what? Now, what is the exterior angle of a quadrilateral? You see, if 4 exteriors is equal to 360, 4 exterior is 360. What is exterior alone? 360. What is exterior?
360. Slide. Picture. 360 out of the number of sides.
There you are. Now, that every exterior angle of any polygon is 360 divided by number of. That's right. You see? Yeah. Now, what if you have an exterior and you want interior? We said this before. Now we are in real properties, drilling them deeper. How do we get an interior angle if you know an exterior? See? Yeah, you show us demonstratively from our structure there. Yes, let me hear. Yes, Grace.
I'm just trying.
But with the reason from that structure.
Okay, if we are finding the interior angle,
yes.
For example, we are using S and A. They are upon that quadrilateral.
S and A.
Yes, so it will be the exterior angle
plus
interior angle
must be
plus 180 degrees.
These are the key formulas. Now for this equilateral, this one we can ask you to draw it at home. Maybe from here, this is 90, and this one. This plus this is what? Does it mean that opposite interior angles in a quadrilateral add up to?
Teacher, even on that apple, then that is alternative angles.
Where? This one? But remember, they are not parallel sides. Did you see that? Now, BA plus C must give us
That's 180.
opposite interior angles add up to? That's true. Now we are going into the summary. I want to give you some numbers and you cut. This one's also an 80. Opposite interior angles are in a quadrilateral only, not in another polygon. It can't work. It can't. Now those things can be proved. You can do research and you prove them. Now I want to take you to the almost the finishing of the lesson. By let me give you some numbers here, and you first handle. Construction of polygons. We did some under construction, therefore I might be hesitant. I must be a bit reserved to handle them. We might demonstrate one. Yeah, are you ready? Let me give you this number. How people are warming to answer it. You are ready? Yeah, it speaks here that find the sizes. Find the sizes of the angles marked A and B. Angles marked A and B in the triangle. Yeah. The triangle. The triangle, and 25 and 25. This is 41. This is A degrees, and B 35 degrees. Somebody can guide us there how we can handle. A mathematician, yes, precious, come and warm yourself. Warm yourself with this, with clear reasonings that because this is so.
I'm just trying.
Why don't you want to give us correct answers? Okay, try.
I'm finding A.
Yes, you are finding A and B.
Only A, teacher.
Only A. It's fine.
Alright. As we said, two interior angles equals to one exterior angle. So we can easily find A in degrees. So A degrees plus 41 degrees equals to the one exterior angle, since these two are interior angles. 125 degrees. So A degree plus 41 degrees minus 41 degrees equals to 125 degrees minus 41 degrees. So this will be a 0. A degrees equals to 84 degrees. 84 degrees. Did they ask us to find A or A in degrees? So this answer isn't yet complete. We shall have to find A alone without degrees. So we shall make A the subject by dividing both sides by 1 degree. The degree and the degree, A equals to 84.
Yeah, thank you, Precious. That's very correct. Yeah, okay. Come on.
I'm finding for B.
Yes, you can find B.
Okay, since we already given A degrees, so we shall have to find this remaining angle. So finding this remaining angle, we can name it any letter of our choice, maybe X. So finding X, it will be X plus A degrees, giving us 180 degrees. Reason being, these two are on a straight line. So X plus A, this A is 84 degrees, is equal to 180 degrees. So what is X? X plus 84 degrees minus 84 degrees is equal to 180 degrees minus 84 degrees. So what is X? 180 degrees minus 84 degrees? 96 degrees. You get 96 degrees. So meaning this is 96 degrees. And then the sum of all interior angles is equal to 180 degrees. So it will be easy to find B degrees. So it will be B degrees plus 96 degrees plus 35 degrees, giving us 180 degrees. So 96 plus 35, 131 degrees, giving us 180 degrees. So you subtract the 131 on both sides to get 49 degrees. So B degrees will give us 49 degrees. But then we are finding for B, as she had explained here, we shall divide both sides by 1 degree to give us B alone, meaning B is equal to 49.
Another? Okay. Thank you, Grace, for being very fabulous. Yes, you can rub.
This is. We can also use the very same method that Precious is here of 2 interior angles are equal to 1 exterior angle. So it is B plus 35 degrees is equal to A. B plus 35 degrees is equal to, since this was 84. So it is B plus 35 degrees minus 35 degrees is equals to 84 degrees minus 35 degrees. B is equal to 49 degrees. 49 degrees out of 1 degree. Take it out as a degree. So it is B equal to 49.
Yeah, she has been very remarkable. Her remarkability is very appreciated. She has been very remarkable. Now, let me give you the last one and we close. Construction of polygons here, I will refer to what we did under construction in topic. That was topic 5. You refer to topic 5 for that sub section, though it is needed here, but we did it there. Now, answer this and calculate the size of an interior angle. Calculate the size of an interior angle in a 50-sided polygon. In a 50-sided. Yeah, you seem unbelievable because people do not believe that 50-sided can exist. You can divide and divide and divide and divide. Guidance. Then we do the last question and we close. Yeah. Yes, Grace. Yes, what do you think? That's very great. That exterior angle equal to
360 degrees out of the number of sides.
That is 360 out of n. 360 out of 50 gives you right. That's 7.2. 7.2. Okay. Yeah, now me, how did I divide with the 8? I just multiplied by 2 and gave it a decimal point. I said 36 times 2 is 72. Since 5 is in the denominator, I give it a decimal point. Yeah. Now, interior angle is equal to 180 minus 7.2, giving you 190 what? 92.8. Is that correct? 190. Oh, that's 80. 172.8. I carried it to 200. That's right. Okay.
Teacher, is it okay if one rounds off?
If the protractor, yeah, it is better turn to a hollow number, since the instrument that measures it to hollow Yeah, that's 170 approximately now. 173. That's fantastic. You'll, I think, try this from home or from your dormitories. Not so? Find the value of A, B, and X. Find the value of A, B, and X. And X. A, B, and X. That means you'll A, B, and X. It's around yeah. I think somebody will think there. Yeah. Now, receive this activity of integration. I've seen somebody thinking very, very deeply, but we shall not allow you to think now. Activity of integration. On activity, the diagram below shows the coffee production in Uganda. The diagram below shows the coffee production in Uganda. From 2015 to 2019. From 2015 to 2019. It's there. Production. The chairman of Karo Farmers Association, Karo, the chairman of Karo Farmers Association, was asked to represent the above information on a pie chart. Was asked to represent the above information on a pie chart. To represent the above information on a pie chart. As a senior 1 student, the problem How do you help solve the problem? Thank you for attending. We meet in topic 8. That means you can do some reading on data collection and presentation. Yeah.